Welcome everyone to, what the heck are we doing? Oh my god, I'm trying to use my new loop deck device to control the stream, and it totally threw off my train of thought because I was focusing on pressing the button, and the way my brain task switches, it totally derailed me. Welcome everybody to SpaceWeek Live with me, Raw Space, on this Sunday, January 23rd, 2022. So let's get right into the James Webb updates. Oh, that is the wrong browser. All right. So 28 days after the launch, the James Webb Space Telescope has finished deploying its 18 hexagonal mirror segments. After the long and complicated spacecraft deployment sequence where they unfolded Webb, the mirror segments had to be individually raised to 12.5 millimeters away from the main body of the telescope, so they have room to maneuver while they're calibrated into their final calibrated optical positions. Webb is now 98.4% of the way to its destination, a halo orbit around the Sun-Earth L2 Lagrange point, about 1.5 million kilometers or 960,000 miles away. Due to the pull of gravity, the telescope's speed has slowed to just 207, actually 206 now, meters per second, or about 460 miles per hour. The next big step will be the L2 halo orbit insertion burn, which will happen tomorrow. After that, it will take about 3 months to fully chill and calibrate the telescope. We can expect first light images in perhaps 4 or 5 months. Back here on Earth, last Monday, a Chinese Long March 2D launched the Xi'an-13 satellite from Taiyuan Satellite Launch Center in the rugged terrain of northeast China's Shaanxi province. According to official sources, the satellite will be mainly used for space environment exploration and related technical tests. I'm not sure what space environment exploration means, maybe monitoring other satellites or keeping an eye on magnetism or solar wind, not sure. But in any case, here is the launch. You can see those thermal insulation panels falling off the rocket, protecting the payload. That landscape in northeast China reminds me a lot of Mexico. Then on Tuesday, SpaceX launched 49 more Starlink internet satellites for their mega constellation. Let's check that out.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicle is pitching downrange.
Stage 1 chamber pressure is nominal.
The first stage booster, oh, that's a good shot. Leave that up for a second. The first stage booster landing was successful on the drone ship A Shortfall of Gravitas.
Stage 1 startup.
Here's the start of our stage 1 landing burn. Cool views of the drone ship approaching.
Stage 1 landing leg deploy. Stage 1 landing leg.
They ended now this time, unlike previous launches, they ended the broadcast before the deployment of the Starlink satellites. Maybe they anticipated that they would not have live video at the time of deployment, but in any case, the Starlinks are up there. Now, last Wednesday, cosmonauts Pyotr Dubrov and Anton Shkaplerov conducted Russia's 51st ISS spacewalk. They continued outfitting the Nauka multipurpose laboratory module, as well as preparing the new Prishal node module for future rendezvous and dockings. Nauka was delivered last July, and Prishal was delivered in November. So that spherical module at the end of Nauka there is Prishal. And it's festooned with looks like 5 docking ports, so I'm not sure what kind of traffic the Russians are expecting to have on their side of the space station, but Prishal is ready to receive whatever may come. Let's see, that same day actually, NASA test-fired an RS-25 developmental engine at their Stennis Space Center facility in Mississippi. They throttled the engine from 80% to 111% for the full-duration 8.5-minute test. Recall that at the SLS rocket core stage will be propelled by 4 RS-25 engines plus 2 SRBs. So again, if you don't recall, the first, I guess 4 Artemis missions will use legacy RS-25 engines that were flown on space shuttles previously, and thereafter they will use the newly developed RS-25 variant that is not reusable and cheaper to build than the original engines. All right, let's see. Then on Friday, a ULA Atlas V rocket launched the USS F8 mission with 2 satellites bound for a near geostationary orbit. The rocket flew in the this was actually the first and only time that the Atlas V flew in the 511 configuration. That's with the 5-meter fairing, a single external booster, and 1-engine Centaur upper stage. So because of the asymmetrical configuration of having just one SRB on the outside, the rocket sort of slides to the side as it takes off from the pad. What do they call it? The big slider. But here you go.
You see the reduce for launch.
10, 9, 8, 7, 6, 5, 4, 3. We have ignition and liftoff of the United Launch Alliance Atlas V rocket carrier SF-8 for the United States Space Force.
Now 10 seconds into flight, vehicles be on the pitch over maneuver, body responses look good.
Now, the U.S. Space Force's Geosynchronous Space Situational Awareness Program, or GSSAP, satellites will track and observe other satellites and objects in and around geosynchronous orbit. They're maneuverable, so they can keep an eye on specific targets when needed. Yesterday, Astrospace conducted a static test fire of their Rocket 3 that will launch their upcoming ELANA 41 mission for NASA.
10, water on, 8, 7, 6, 5, 4, 3, 2, 1, 0. Engines running. Shut down.
Now, the launch of ELANA 41 has been delayed a few times, but it's expected about a week from today, next Sunday. So I'll mention it again in SpaceWeek next week. Finally, this morning, SpaceX Cargo Dragon CRS-24 undocked from the ISS, bound for a splashdown in the Gulf of Mexico. Last week, I went over the cargo manifest in detail, if you're interested to know what it's bringing back. But a lot of science experiments, equipment that will be refurbished and relaunched to the ISS in the future, and some nice experiment containers. So if you're not familiar, when either Dragon, the Cargo Dragon or Crew Dragon, undocks from the ISS, the nose cone is open, as we see there, and the trunk, that is the part at the back with the fins and on the other side that we can't see the solar panels, is still attached. But prior to deorbit, they will close the nose cone, and they'll also jettison the trunk. So the trunk will burn up, but the capsule will safely splash down in the Gulf of Mexico. All right. So taking a look further back into space history, Tuesday, January 25th, will mark the 18th anniversary of the landing of the Opportunity rover on Mars in 2004. OPI, as it came to be affectionately called, was designed for a 90-sol mission. A sol is a Martian day, about 24 hours and 37 minutes. But the rover continued operating for 5,118 sols. Last contact was on June 10th, 2018. Thursday, January 27th, marks the 55th anniversary of the tragic Apollo 1 fire in 1967, which claimed the lives of astronauts Gus Grissom, Ed White, and Roger Chaffee. The following day, Friday the 28th, will be 36 years since the 1986 Space Shuttle Challenger disaster. On board were Commander Francis Scobie, pilot Michael Smith, mission specialists Ronald McNair, Ellison Onizuka, and Judith Resnick, payload specialist Gregory Jarvis, and payload specialist Krista McAuliffe, a teacher. She would have been NASA's first civilian astronaut. The end of January and beginning of February represent a very historic time in space. The Apollo 1 fire, the Challenger disaster, and then on February 1st, the Columbia disaster, all occurred around the same time of year, coincidentally, but it makes for a somber couple of weeks. There's also the Apollo 14 mission, which is tossed in there, which I'll talk about next week. As for launches and live streams this week, Monday, January 24th at 3 p.m. Eastern, 2000 UTC, is NASA Science Live, What's Next for the James Webb Space Telescope. I'll have a live stream of it for you right here on Raw Space. And it is not clear from the program description whether they will include live coverage of the orbit insertion burn, which is scheduled for tomorrow. But so I don't know if we will actually have live coverage of orbit insertion, but it's possible. In any case, I will be providing a copy of that here for you to view. Then on Tuesday, January 25th at 6:40 p.m. Eastern, 2340 UTC, a Chinese Long March 4B is expected to launch an unknown payload into an unspecified orbit. There will not be a live stream, and no more information was available about that launch. On Thursday, January 27th at 6:11 p.m. Eastern, 2311 UTC, should be the launch of a SpaceX Falcon 9 with Cosmos SkyMed Second Generation 2, or CSG-2, a radar surveillance satellite for the Italian Space Agency, ASI. One launch schedule website did claim that it was delayed until the 29th, though, so keep an eye on the calendar and make sure to click the bell for Raw Space to activate notifications, because launch schedules change often. Then on Saturday, Saturday, January 29th at 3 p.m. Eastern, 2000 UTC, we have another Falcon 9 launch with the 36th batch of Starlink satellites. All right, I'd like to take a moment to extend a hearty thank you to all of our channel members and supporters for their steadfast, support of the channel. That was a little redundant, but y'all make this a little more possible than it would have been otherwise, so it's greatly appreciated. There is, of course, a cost associated with keeping all this going. So that definitely helps. Let me get to your questions. Good. We have Chris today. All right. So Rockin' Robins 13. You know what? Let me put the there. The question captions. All right. Rockin' Robins 13 asks, what other spacecraft are hanging out at the L2 bar? The L2 bar. That's a good question. Let's see. Spacecraft orbiting L2. I don't know. Oh, list of objects at Lagrange points. Here we go. L2. All right. So this is per Wikipedia. So real quick, Lagrange point brush up. L1 is between the sun and the Earth, and L2 is on the opposite side of the Earth from the sun. L3 is on the opposite side of the sun, which we never go there. And L4 and L5 are ahead of and behind, or vice versa, the Earth by, 66 degrees? Something like that. All right, so at L2 in the past, we have had, from 2001 to 2010, was NASA's Wilkinson Microwave Anisotropy Probe, or WMAP, to observe the cosmic microwave background. From 2003-2004 was NASA's WIND spacecraft. Apparently it went to L2 and then Earth orbit and then L1. Interesting. From 2009 to 2013 was the ESA Herschel Space Observatory, which exhausted its supply of liquid helium and was moved from the Lagrange point in June 2013. Also, from 2009 to 2013, at the end of its mission, the ESA's Planck spacecraft was put into heliocentric orbit and passivated to prevent it from endangering the future missions. And from 2011-2012 was the Chinese Chang'e 2 probe, which was again put into a heliocentric orbit it's basically a graveyard orbit around the sun to get it out of the way of future L2 probes. Currently at L2 are the ESA's Gaia probe, which is hunting for exoplanets, the joint Russian-German high-energy astrophysics observatory Spectre-RG, and the joint NASA, ESA, and CSA James Webb Space Telescope, which will be arriving tomorrow. So 3 probes. Good question, and thanks for that. All right. Okay. Dan Todd, is a halo orbit an orbit whose center is other than the center of mass of its object? So the L2, well, all of the Lagrange points are imaginary points in space. Let me try to pull up a graphic for you. Okay. All right. All right, so here we have the Sun, the Earth, and the Sun-Earth Lagrange points. You can see there L1 through L5. And the swirly topographical-looking lines there represent the relative gravity in each of those points, like the balance of gravity between the Sun and the Earth. So the Lagrange points are imaginary points in space, and what they represent is a balance of the gravity between two celestial objects. And because of that balance, you can actually orbit that imaginary point in space. And so as you go farther away from the sun pulls on you, and you go farther away from Earth, the Earth pulls on you. You end up in an orbit, a halo orbit around the Lagrange point. You can't sit exactly at the Lagrange point. You will drift, but you can orbit around it with minimal use of fuel for station keeping. So that's what a halo orbit is. It's basically orbiting in a circle around the imaginary point in space at which the gravity between the Sun and the Earth, or any two astronomical bodies, is balanced. L4 and L5 are actually gravitationally more stable than L1 and L2, but L1 and L2 are typically more useful in terms of science because they have a fixed position relative to the Sun and the Earth. Like the L1 Lagrange point always sees the illuminated side of the Earth. The L2 Lagrange point is always on the shaded side of the Earth, although it's not in the Earth's shadow because it's too far away. But, all right. Tig asks, anything new from Mars? Anything from the new rover there? So, for a while now, I've been collecting and, well, continuing to collect daily raw image downloads from the Perseverance mission on Mars. And I've been trying to think of what to do with that archive, because it's, you know what, let me look it up real quick on my hard drive. Mars 2020, raw images. So over the course of the past couple of years, right? Couple of years? Has it been that long? That not a couple of years, the past year that it's been up there. Perseverance has taken more than 48,000 images, and with its numerous cameras. And so I've downloaded all of them. I have a script that downloads them daily from a NASA site. And I'm not really sure what to do with them, because they're raw images. They're not processed. Like, for example, the big panoramas that you're used to seeing from the surface of Mars, those are stitched together from many individual images. So let me show you an example of so this is, let me go to a recent date. So 122 HazCam, 121 MastCam. There we go. Okay, this looks reasonable. All right. So here we have one image from the MastCam left. This is the this is the left side of the stereoscopic camera on the main mast of Perseverance. And the image is of a rock, obviously, with some weathering and some dust deposition. The file itself is, what do we have here? 1200 pixels by 873 pixels. So not terribly big, but again, it is hard to get large quantities of data from across the solar system, because bandwidth is very slow. Throughput, I should say, is very slow from like the deep space network of radio telescopes that receive these signals from afar. So anyway, yeah, I've thought of maybe setting up a live stream where it shows images, you know, from the raw feed, but like a lot of them are of the sundial. You know, a lot of them are basically duplicated. So we see here multiple images that are essentially the same. We see a lot of images that are like, what the heck am I looking at? Or they were incomplete in their, you know, this is why, so we see some fuzzy rover part in the foreground with rocks in the background. So providing a live stream, an automated live stream that like randomly displays an image wouldn't be terribly interesting, I don't think, because there's just so much repetition and so many, you know, like look at this frame. What in the world are we seeing here? This is why scientists are needed to interpret, and here we have static. We have like a small static frame. This is why the scientists are needed to actually interpret what we're seeing, process the images, do their color correction, etc., and provide. What is this? What is this? Jupiter? No idea. Obviously, it's not Mars. Oh, maybe that's the sun with a filter. But in any case, so yeah, we're always getting images, but I haven't really been keeping up with the science press releases for Perseverance. So I don't really have news on up-to-date findings, but I should look into that and provide some information maybe in SpaceWeek one of these weeks. Let's see. Rockin' Robbins 13 says, did you know that more Falcon 9s have landed than Atlas 5s ever launched? I do know that because you mentioned it during the live stream. Otherwise, I would not have known that. But yes, Falcon 9 is a very prolific rocket. Dominic Bayless says, do all the satellites and rocket boosters' space debris have an effect on the amount of sun we can get on our planet Earth? Reference as looking at stuff in space, website, and other platforms. Any object that's orbiting the Earth does, mathematically, does affect how much sunlight we receive on the planet. A grain of sand orbiting the Earth does have some ridiculously microscopically small effect on the amount of sun we receive on the Earth. But it's not an effect of sufficient magnitude that you could measure it from the Earth. We have a few thousand objects orbiting the planet, and these are objects ranging in size from tiny to the size of the biggest satellites. And then, of course, there's the 2 space stations up there, which are, larger than any other satellites. But as far as, affecting that's a few thousand objects. Let's say, consider a mall parking lot, like a mall parking lot full of cars, but then take those cars and distribute them over the entire surface of the Earth. You're not going to encounter another car for a good long while. They're going to be very widely distributed. And, the presence of those cars on the Earth is not going to interfere with your usage of land for farming or whatever. So, yes, mathematically speaking, any object that we have orbiting the Earth does affect the amount of light we receive, but it's a tiny, tiny, minuscule fraction of a percent. That it would affect us. We would need to have millions of objects orbiting up there in order for it to make any kind of substantial difference in the amount of solar radiation we receive. Interesting question, though. MVM Motovlog Music says, the Raw Space t-shirt fits well, looks good, and makes him a fashion icon. That is good news. Oh, I see. So, any of you interested in Raw Space merch, there happens to be a store. I have a new Raw Space storefront that I'm in the process of getting ready to roll out, but it's not quite ready yet because I've been slacking. But I need to get on that and finish it up. It looks nice. But it's with a different merch vendor rather than the Teespring that we've always used. Let's see. Jimbo Thunderhawk. If the Russians invade Ukraine, what would the environment look like on the ISS? So this is talking about the effects on the International Space Station of political events down on the surface. Well, political concerns are something that certainly have been discussed by NASA, Roscosmos, Russia, and my thought is I haven't been privy to those discussions, but they have protocols in place for that sort of thing. And my feeling is that the ISS would function normally, even if relations were strained between the United States and Russia, because the ISS is a different entity. I mean, it would be detrimental to both parties in order for or rather, it would be detrimental to both parties if they were to somehow segregate the space station and say, you Russians, you stay over on your half and we're going to stay over here. That would be stupid and petty. But who knows? You know, politics is often, even though we try to keep this channel clear of politics, politics always plays a part in space because space is valuable territory and it takes a lot of money to get there. And so most of the players in the space sphere are governmental. Yeah, I think that the astronauts and cosmonauts would continue to get along fine because they're professionals, and I believe that their jobs and their positions transcend petty, earthbound politics. Mark Desire, because I mentioned earlier that Krista McAuliffe was NASA's first civilian astronaut. Mark Desire says, I thought Neil Armstrong was a naval aviator and test pilot, not civilian. Yeah, Armstrong was a naval aviator. So he was not a civilian. Right. So, yeah, I'm a little rusty on my Apollo crew histories, individual histories, but yeah, I'm pretty sure all of the Apollo astronauts were military. Charles Paul says, if they bring mice, are they bringing cats too? Haha. And if they take the mice to Mars, haven't they watched Biker Mice from Mars? I myself am not familiar with Biker Mice from Mars, but it sounds like a top-notch film. I should check that out sometime. But I don't think there have been any cats in space. There have been cats there have been other creatures in space. There have been worms and fish and monkeys and dogs and mice, of course, tardigrades and other creatures, but I don't think there have been any cats in space. There have been cats on the Vomit Comet, the parabolic airplane flights that produce short periods of 30 seconds of zero gravity, followed by 30 seconds of 2G. Yeah. Rockin' Robbins 13 says, actually, we have a broken down solar observation satellite at L3. That's interesting. You know what? If I go back to this page, which I still have up. Okay. Well, according to Wikipedia, L3 is the Sun-Earth Lagrange point located on the side of the Sun opposite the Earth, slightly outside of Earth's orbit. There are no known objects at this orbital location. So, if there is a satellite there, Wikipedia is unaware of it. So if you could maybe find a source for that info, maybe we could update the Wikipedia page. Geraldine Braun says, when it comes to the rocket engine's sound, I think winter makes the sound much better. What do you think, Raw Space? Well, winter, the atmosphere in winter is definitely different than it is in summer. In summer, there's more humidity and a different temperature to the air. The air in winter is crisper, colder, and less humid, and that does have an effect on the sound. As for what effect it would have, I'm not really sure, because I've not seen a rocket launch myself in person, and so I wouldn't know what to compare it to. I'd love to get some good audio of rocket launches. Unfortunately, most of the places that people have, first of all, most rockets are launched from a coast, an ocean coast, whether it be Florida, California, Kodiak Island, New Zealand, Tanegashima Space Center, even Satish Dhawan in India. The notable exceptions are the interior Chinese launch sites, which aren't accessible to the public, and the Russian launch facilities in Kazakhstan, Baikonur, Vostochny in the east, and Plesetsk in the north. Those are all land-bound. But so most of the viewing sites for launches, well, they're going to have people at them. And so when the rocket launches, yes, you're going to hear the rocket, but you're also going to hear cheering people, which it's very hard to get away from that because there are very few places you can watch a launch from. So getting clean audio of a launch is actually quite difficult. But yeah, it would be interesting to take a look at the differences in sound between launches in different atmospheric conditions and different seasons. So that is intriguing. Thanks for that. Tig also asks, anything about the probe that is getting close to the sun, the Parker Solar Probe? I don't have any updates on Parker. Every time it makes a close approach, we get a new video released from NASA of what it saw, but I don't have any specific updates on Parker. But if you go to the Parker Solar Probe NASA page, I'm sure they have some information there, but I don't have immediate access to that. Dominic Bayless says, is the sun destination programmed for satellites or debris in their flight coordinates to get a shot of them when their time is up? If you're asking if we're going to get a picture of the Lagrange point, no. First of all, there are no pictures of the James Webb Space Telescope, for example, at least after it was detached from the upper stage of the Ariane 5 rocket that launched it. Once it was out there on its own, there's no pictures of it because, first of all, the business end of the telescope, the mirrors and the the tripod and the receiver are all in utter darkness. They're on the far side of the Earth, pointed away from the Earth and the sun, and that's by design. They have to be in darkness. They have to be in and that's the whole purpose of the sun shield on the James Webb Space Telescope. That 5-layer foil is to eliminate as much solar radiation as possible so that the core of the telescope can be brought down to a ridiculously cold temperature, just a few degrees above absolute zero, so that it can most accurately detect the faint infrared photons being emitted from the far reaches of space. And so to that end, James Webb is illuminated only by starlight, which is not too bad. I mean, if you think of a moonless night on Earth that's clear, you can still see, sort of, but there's really nothing to see of the telescope, and there's certainly not a satellite craft or a microsatellite or whatever that's going to be taking photos of the satellite when it gets to its destination. But we do have telemetry from the telescope and any other satellite out there, and we receive its data, and so that's, we know it's out there and we know it's doing its job. Let's see, MVM Motovlog Music. Mars images are exciting to look at. It would be a great live for your channel. I mean, I could try to put something together. I certainly have the image archive for it. It automatically updates itself. So, sorry, all this talking, it's killing my throat. But I could try to put something together. I mean, there is the satellite time-lapse stream that we have, which sees almost no viewers. I don't think it's because the content isn't compelling. I think it's because the YouTube algorithm is broken. For some reason, it has deprioritized my 24/7 streams, and I'm not sure why. But so chances are, if I were to put in the effort to to create a live stream of Mars raw images, chances are that it would probably see the same pattern of, maybe 30 to 50 viewers in the first hour or two, and then settling down to about between 0 and 4 at any given time thereafter. But you never know. I could put it together and see what happens, because maybe this time would be different. But moving on, Ian Stobie says, stick up a live stream anyway. Have a public vote on most interesting. Probably need slow data rate, image every few minutes. Music will make it interesting. Of course there would be music. Similar to how live animal cams do it. Yeah. On live wildlife cams, viewers cite timestamps when anything interesting happens. Yeah, it's worth a shot. I mean, I've got the data, so I may as well use it. Elmo Jones Music Orpheum, with names for days, says, do the Russians have a long-range space exploration agenda to the moon or to Mars? I'm not privy to Russia's plans for space. I don't think they have any plans to go to the moon or Mars. I don't know if they have planned that far ahead, or maybe they have thought about it and decided no, but there aren't any Russian vehicles I'm aware of that are being developed for the moon or Mars. Just, solar system missions, which is what they've always had, robotic probes and whatnot. But so I'm not aware of any. I'm not aware of any long-term Russian plans for outside of Earth orbit. Oh, okay. Snow Kittens says, of course, nice. Snow Kittens with the cats says, of course there have been cats in space. The French did all of it. Or the French of all. Okay, the French did it. Félicette, I guess, was the cat's name. And she returned alive, which is more than can be said of poor Laika, the Russian space dog. Iwo Wisniewski. So I stand corrected. Thank you, Snow Kittens. Iwo Wisniewski says, why is the cargo dragon's trunk lined with some white stuff and the crew dragon trunk is not? I am not sure. Maybe, I don't know. I'd have to look at pictures of the two trunks to really address that. But maybe it's just a matter of, like, maybe the next Crew Dragon flight we see, the trunk will be lined with white stuff. Maybe that's just a new thing that they do. I'm not sure. Rockin' Robbins 13. Neil Armstrong was a civilian while an astronaut. He left the Navy Reserve in 1960, but he had been in the military. It's fair to say he was a veteran, but he did not hold a rank while at NASA. So he was a civilian, but he had been in the military. So there you go. Rockin' Robbins 13 also says, Cameron Fraser says, unlike many astronauts who were serving members of the armed forces, seconded to the space program, Armstrong had resigned his commission and left the Naval Reserve in 1960. His regular commission was terminated in February 1952, when he was assigned to the reserve, and he was released from active duty in August 1952. He had been a civilian employee of NACA beginning in 1955, and continued with NASA when it was established in 1958. So thank you for that clarification. Also, Astronomy Livestream with David Brewer said that Apollo 17 astronaut Harrison Schmitt, the famous geologist, the only geologist to have visited the moon, was a civilian. All right. So, Okay, so back to the live chat. Tig Rahoff with a reference to my silver play button, which is in the background over here. Boop, boop, boop. I put it on for now. I put it on the bookshelf. At some point, I'm probably gonna move that tapestry and put some more things on the back wall once I get a proper window covering there. I'm not sure, but we shall see. So, Evgeny or Eugene, I think it is this Russian person's name, says, what do you think about Kerbal Space Program? So I've owned Kerbal Space Program for quite some time, but I've never actually played it. I really should, because not only is it reportedly quite fun, but it's also educational on the basics of orbital dynamics, or orbital mechanics, and rocketry. So, Rockin' Robbins 13 says Russia should go back to Venus. I think we do have a couple of Venus missions coming up, actually. Ian Stobie says, call it Live Mars Alien Watch. Ask watchers to report all alien sightings. Be cheap and populist to please the YouTube algorithm. I think that's right. I think I need to aim low and be sensationalistic and unscientific, and that will bring in more viewers. Except that ain't gonna happen. So, sorry, algorithm, you can kiss it. Okay, Snow Kitten says the Russians want to go to the moon with China, manned, which makes sense that they would collaborate. There's also Luna 25, which is scheduled to launch this year. ExoMars with ESA, planned for September. Because it has, after all, been almost 2 years since the Mars 2020 mission was launched. And as you may know, every 2 years we get a Mars launch window, so this year is no exception, and there will be at least one Mars mission launched in this window. This year's window. All right. So, I think that will wrap it up for this week. Thank you all for coming. Thanks for your patience with my rambling. And I hope to see you in this week's live streams. So until then, keep it raw, take care, stay healthy, and I'll catch you later. What am I doing? Here we go.